Many people, while looking at the dark clear sky at night, might not realize how many phenomena are masked by the universe. Only one example would be the gamma rays, about the existence of which we are aware, and that's where our knowledge ends. What really are gamma rays and how could we use them? Even though we are able to use them in medicine, there is still a lot of hidden potential beneath it. Therefore, we state our thesis that they might be one of the strongest energy sources that humanity will have ever seen.
In the electromagnetic spectrum, gamma rays have the smallest wavelengths, so short that they are measured in nanometers. They originate from the most energetic objects in the universe, such as supernovae and nuclear explosions, and are able to travel with the speed of light because they, as a pure electromagnetic energy, have no mass. Another unique property is that they're able to pass through many material objects, including human body. To emphasize, even concrete requires a layer of 5 to 8 meters to fully stop the gamma radiation. Because of this, the most efficient way of protection against them is to use a material of very high density, such as lead.
Gamma rays require a special amount of attention because of their high penetrating power. While alpha rays have seemingly a lot stronger effect on our organism, they are not able to penetrate the body, and thus the internal organs. Alpha and beta waves are destructive in case of getting inside the living organism, for example, by swallowing or any access to the respiratory or blood system of human body. Gamma rays, however, do not require any way of getting into the organism, as their high permeability allows them to access our internal organs without physical contact with the radiation source.
The main differences between alpha, beta and gamma electromagnetic rays are connected with their wavelength, frequency and produced power. Other than that though, alpha, beta and gamma rays are very similar, and such are their uses.
One of the best known uses of gamma rays is in external beam radiotherapy, also known as teletherapy. The so-called Cobble bomb that produces stable beams of 1.17 and 1.33 electron volts is one of the few known methods of curing cancer. The gamma rays are able to destroy living cells in organisms, including the carcinogenic ones. By covering almost entire patient's body with heat barrier, except for the places where sick cells appear, we are able to destroy them. This is a main social, economical and health factor because of its daily application on hundreds of human lives all around the world. Despite the fact that teletherapy and chemotherapy are strictly connected with each other, they cannot assure 100% survivability, but they can increase the survival factor for about 65%.
Gamma rays' destructive power is also used in other situations. Some places like nourishment treating departments or medical facilities require absolute sterile environment. Equipment used in such places is highly exposed on bacteria activity because the setting is perfect for their development. As these rays can kill living cells, they are ideal for precise cleaning of medical tools or food. Moderate gamma radiation's influence on basic layers of fruits and vegetables that come directly from farm and are covered by chemical substances such as sprayings is able to kill all unwanted compounds. The same process occurs in hospitals during sterilization of medical tools. This procedure is commonly known as sterile irradiation. This makes an obvious health factor as we are able to eat clean food that is not contaminated with pathogenic bacteria and be treated with medical equipment that is just as clean. During this process, it is also possible to save water and not use any dangerous to environment substances, which is an obvious environmental factor.
There are also several different applications for rays penetrating power. As we mentioned, they are very useful during a cancer treatment. However, it is also possible to use them as an alternative to X-ray scanning. This kind of diagnosis is connected with nuclear medicine's imaging techniques, known as positron emission tomography, shortened PET. During this analysis, the nuclear isomer technetium 99M acts as an emitter which sends gamma radiation at similar energy range as diagnostic X-rays. It is able to find, based on human's body metabolism, the places where carbohydrates are present unusually big amounts, what points toward cancer cells. In a similar way, they are used in CSI organization, the Container Security Initiative. Transport of cargo containers that form about 90% of world's trade transport market is exposed to many different ways of transferring illegal products. Because of this, it was necessary to find a way of quick and precise control over ships and planes' contents. Huge gamma detectors scan up to 30 containers per hour to ensure citizens' safety, as they allow to see every tiny element of transported cargo. Both of these uses are social factors which have a reflection on human safety.
But how does this connect to the universe and huge energy potential? Well, one of the natural sources of gamma radiation are gamma ray bursts. These spontaneously occurring phenomena are emitting an insane amount of power. It is even said that a 10-second burst could unleash energy equal to what our Sun will send during its entire 10 billion years lifespan. For better comparison of their power and to make it more understandable, we would even say that they have been the biggest energy eruptions since Big Bang. To connect this with our thesis, we hope that in the near future humanity will find a way to capture the power emitted by those bursts and transform it into usable and nearly endless source of electricity. This could solve many social and economical problems such as depletion of natural resources, but for this day we cannot be sure what consequences would we suffer from such experiments if they would ever happen.
On the other hand, there are many different uses of gamma rays in astronomy. Scientists can use them for detecting mass of the planets and determining objects on its surface. What's quite interesting is that humanity invented few ways of measurement of gamma rays emitted by planet's Mercury acreage, precisely its atom's nuclei, that are struck by cosmic rays. During collision of those two different rays, rocks and soils emit unique type of energy, which are in fact gamma rays. This process helps scientists in exploring natural geologically important elements, such as for example hydrogen, magnesium or titanium. This is a potential economical factor, as we could discover new elements which could lead to technological progress.
All of this just shows how little do we know about space and how much more is there to be learned. The incredible strength hidden in gamma radiation is even now used in a large variety of categories, and with current speed of advancement in technology, it's highly possible that in no time it might help us overcome one of the world's biggest problems, the lack of energy. Undoubtedly, the future of mankind lies in the conquest of space.